Hi all, welcome to Network Path. In this video, we will understand what is a metric in routing protocol domain. When a router has more than one possible path to reach the same destination, okay? Now you can see here A to C, you can go directly A to C or through B. So when a router has more than one possible path to reach the same destination, it needs a way to figure out which path is the best path actually. That's where metrics come into play. A metric is simply a value that gets assigned to each route. When the routes are assigned to the route table, every route has a metric value that helps the router to rank them from most preferred to the least preferred. Think of it like a scoring system that guides the router in making the smartest decision. Now let's look at an example to see why these metrics are so important. Let's look at this routing table. The first three networks are directly connected to router A. So no extra routing is needed to reach them, right? That's very straightforward. Now the last four networks can be reached through either router B or router C. You can go back and see the topology. And that's also correct, right? The last four networks can be reached through either B or C, right? But the real question is if 192.168.7.0 can be reached through both B and router C, which path should router A actually choose? So you can see in this figure, right? So 7.0/24 has two paths for router A. It can directly go to router C or go through router B. Then there is a question which path the router A should choose. And that is where metrics come into play. Metrics are like scoring system, as I told you, right? So they know which path is good, so they give them a metric value. For example, RIP is a routing protocol that stands for Routing Information Protocol. It is one of the oldest routing protocols, and it keeps it very simple. It picks the path with the fewest hops. Now you can see to go from A to C, there is a single hop if we go from the above path. But if we go through B, there are two hops, right? A to B is one hop, and B to C is another. So if we use RIP, right, RIP protocol, then A to C is the shortest path because its metric is the hop count, and the hop count is only one, right? And on other hand, there is a protocol named EIGRP, which is more sophisticated. We'll talk about it in later chapters as well. And it looks for both the slowest bandwidth and delay as well. So it is a combination, sort of combination, but with a complex formula, right? Now let us look at the different types of metrics. The first one is hop count. If you use Routing Information Protocol RIP, it states that less the number of hops, the most optimal path it is. So if I talk about this link, let's say router A is looking to reach 7.0/24. It has this one hop path and it has this two hop path. Then basically it will choose this path because it has only a single hop. But it is not a good metric because let's say this is a 100 Mbps link and these two links are 1 Gbps links, and you want to transfer a 10 GB of file, you can clearly see that this path will take less time compared to this path because 100 Mbps link will take a lot of time to send 10 GB file, and 1 Gbps 1 Gbps links will take drastically less time. So hop count is not that good measure. But if you talk about an environment wherein all the links are homogeneous, let's say all links are 100 Mbps, then hop count is a good metric. The second metric here is bandwidth. And in this case, a bandwidth metric would choose a higher bandwidth path over lower bandwidth link. As I told you, if there is 1 Gbps link here, and there is 100 Mbps link, this one is 100 Mbps, then if I choose bandwidth as my metric, then the router will share its entire load on this path. That means all the traffic that is coming from here and looking to go at 7.0/24, it will be forwarded through this path, and this makes this route much more loaded compared to this path. This path might be less less loaded, and it has less delay. And that is why only taking bandwidth into consideration will not be an optimal solution, right? Because you can load balance things. Generally, you do not have 1 Gbps, 1 Gbps links on two-way, and there is 100 Mbps other way. Generally, the links will be in a homogeneous fashion. Okay, so all the links would be of similar bandwidth. So only taking bandwidth into account is not an optimal solution. The third thing is load. This metric reflects the amount of traffic utilizing the links along the path, and the best path is the one with lowest load, right? Unlike hop count and bandwidth, the load on a route changes, and therefore metric will change. Care must be taken here, right? If the metric changes too frequently, route will start flapping, right? Route flapping means if router A has added into its route table that if I want to reach 7.0/24, I will go through this path. Then if I choose this load metric, then it will change when the load changes, right? Because at one instant the load might be more on this path, and at other time the load might be on this path, right? And that is why the route will change more frequently on the routing table of router A, and that means the route flapping is going on. Route flapping basically means that the route on your route tables are frequently changing for a destination, right? So only taking even taking load into consideration only is not a good solution, right? The next metric is delay, and delay is a measure of time a packet takes to traverse a route. A routing protocol using delay as metric would choose the path with least delay. There might be many ways to measure delay. Delay might be taken into account not only the delay of links along the route, but also factors such as router latency and queuing delay. There is a concept that is known as queuing delay. That means if a packet which is coming through this link will have to wait for packets in front of it to get forwarded through various links, and then your number will come, and that is queuing delay in very short, but it is a major sort of delay when we talk about delays and latencies. And on other hand, the delay of a route might not be measured at all. It might be a sum of static quantities defined for each other along with the path. So delay is again not a very optimal solution. So you must have noticed till this time that if I take only hop count into measurement, only bandwidth into measurement, or even only load into measurement, we are not getting the most optimal path. And that is why EIGRP, which has a very sophisticated formula, takes into account a lot of things, right? And okay, so next metric is reliability. It actually checks that which path is more reliable. Let's say this link has been broken into past several times. That means the reliability of this route is low, and this route is more. So your router A will use this path for its routing protocol. Okay, that simply means using reliability to choose the most optimal path. Okay, then comes the cost. This metric is configured by a network administrator to reflect more or less preferred routes. Okay, so cost might be defined by any policy or characteristic. It might reflect that a network administrator wants to prefer a route more than the other. Therefore, cost is a term of convenience describing a dimensionless metric. So you as an administrator can change it. The term cost is often used as a generic term, right? So don't confuse this term with other. For example, RIP chooses the lowest cost path based on the hop count. But this cost is different from what I'm talking about right now. This cost is simply putting values in front of your route that, okay, the cost of this route is this, the cost of this route is this, and you as an administrator choose what is the count, right? So I hope you understood these basic, basic metrics that are used, but now the routing protocols that we use do not use these basic metrics because they do not provide you an optimal path. That is why OSPF or EIGRP, which are modern routing protocols, use a more sophisticated and complex strategy to calculate best path. Okay, and in next video we will talk about convergence. I hope you like this video. If you have any doubt, you can write it down in the comment section. Thank you so much.